Yo, 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 Coach Ray is back. Don't forget to like, subscribe, and share. And make sure you don't forget to click that bell button for push notifications. All right, this lesson is on graphing absolute value. Let's get started. Okay, the first thing I want you guys to know, and the most important thing I'm going to teach you by far, so make sure you're listening very close. Okay, this equation right here. All right, this general equation, the reason I'm saying it's general is because there are no numbers in here, it's just got variables. Okay, this equation will be used over and over again all year long. It'll look a little bit different in each unit, but this same equation is always used. All right, so just so you know, like we have absolute value bars in here right now. In the next unit, which is coming up, those will be parentheses, and you'll have a little square right outside here. So it always looks the same, and every part of it always acts the same too. So for example, in this A right here is always talking about the width and flipping it, which we'll talk a little bit more about that in a second. But so if I'm making something wider or more narrow, that's because of this A out front. And also if I flip it up or flip it down, that's because of this. H, the one thing I need to make sure you really understand about H is it does shift our function, whatever we're graphing, it shifts it left and right. But what's really important is this minus here in front of this H means like the opposite of H. Okay, so it's moving in the opposite direction of what you would think, basically. So if I put a 5 in here for H and it would say x minus 5 here, then minus 5 would make me think I'm moving to the left 5 because the negatives are to the left, positives are to the right. That's not the case because of this opposite of H thing. Minus 5 would mean move to the right. All right, and then it's also true if it's an x plus 5, you're actually moving it to the left. So super common mistake. You got to remember that inside this group here with x, it's always going the opposite direction of what you would think. All right, since this k has a plus in front of it, you don't have to worry about all that opposite stuff. If it says plus 10, you move it up 10. If it says minus 10, you move it down 10. Because right up here you can see where it says all this number is doing is shifting something up and down. All right, now before we get into our example, and the vertex is actually at H and K, we'll talk about that here in a second too. All right, before we get into an example, I want to go straight to Desmos. Okay, and I want to type in y equals the absolute value of x. And I want you to write something down right now. Y equals the absolute value of x is the parent function. Okay, y equals the absolute value of x is the parent function. We're going to talk about parent functions all year long, so it's really important that you have a good understanding of it now. And here's my definition of a parent function. This is not out of a textbook. This is just my definition of it. It's the most basic and simple version of a graph. I'll say it again. It's the most basic and simple version of a graph. Okay, and what I mean by that is A is blank. Okay, there is something in front of the absolute value multiplying it. It's just 1, so we didn't have to write it. There's no number in here with x. There's no number in the back. So that's why this is the most basic version of this, because we really tried to put as little numbers in there as possible. Right? Most of the ones you're going to graph are going to have numbers mixed in there, so you'll have to know what that does. Now, here's the reason for a parent function. Okay, let me put it in like human terms before I put it into math terms. But in human terms, if I ask you the question, am I rich? Okay, that answer is not simple. Okay, if Bill Gates were standing next to me and I asked the class if I was rich, you'd probably say no. That man standing next to you is rich, you're nowhere near him. Okay, but if I take the homeless guy out on baseline and stand him next to me and ask, am I rich? That man might even agree that I'm rich. So it's relative is what I'm saying. Right? So it could work like this as well. If I ask you, am I skinny? Okay, your answer would probably be comparing me to what you think is normal, right? So whatever you think the normal person my age should look like, you would compare me to that and say whether I'm skinny or overweight, right? So that's what we're doing here as well. If I put an absolute value v up here somewhere, and I asked you, is that skinny? What we compare it to is the parent function. If it's skinnier than this parent function, then we say it's skinny. If it's wider than the parent function, then we say it's wide. That's why we have parent functions, so that we have something to compare all of our graphs to. All right, so let me put a different one up there. I'm going to just mess with a. So y equals, I'm going to make a 2. So 2 in front of my absolute value of x. Okay, so you can now see that my new absolute value v just got narrower than the parent function. So we would say this is narrower skinny. And if you want to use your algebra vocabulary, which is always amazing, we would say this is vertically stretched. If I grabbed a sheet of paper and I were able to stretch it up and down from the top and the bottom and vertically stretch it, that would take whatever picture I'm looking at and make it thinner. If I took the top and the bottom and I compressed it and pushed it together, that would take whatever I had and make it go wider. Okay, so in algebra, we say things are vertically stretched or vertically compressed. But same thing is narrow or wider. Okay, so this purple absolute value v is vertically stretched. All right, I'm going to stretch it more. Y equals 3 absolute value of x, and it continues to get narrower. All right, so obviously you could kind of make this conjecture. You could say that the bigger I make a, the more narrow or the more vertically stretched it gets. Everybody's fine with that? Okay, so if I made this 13, it'll be easy. If I made this 13, it's going to start getting really narrow. All right. So let me do a different one. I'm going to do y equals, and I'm going to make a negative 2. Negative 2 is smaller than 2. Everybody in the room would agree with that, I hope. Negative 2 is smaller than 2. And if I use the logic we just talked about, since negative 2 is smaller than 2, it seems like that would make it wider. But that's not the case, and I want us to look at it. Y equals negative 2, absolute value of x. I would argue that my purple and my blue absolute value v's are actually the same width. I don't think the width changed there at all. The only thing that changed was it flips. Okay? So positive or negative a does not affect width. Positive or negative just affects whether it's upwards or whether it's flipped downwards. Okay? What about if I want to make it wider? If I want to make it wider, I've got to do a number smaller than 1, because my parent function a is 1. All right, so a number smaller than 1 would be like 1/2 absolute value of x. So now we're wider than that green parent function. All right, if I made it like 1/20 or a real small decimal, so see how wide it gets down here. Okay, so that is a. A is going to make it narrower or wider, and then positive or negative a is going to flip it either up or down. All right, so now let's kind of look at if I put a number in here with x. I'm going to start with doing plus a number. If I do x plus 2, notice it took my purple v and it moved it from here over to here. Moved it to the left 2 places. If I did x minus 2, moves it to the right. Yes, ma'am. Yes, the question was referring to a. If I make a decimal or a fraction, that's going to make it wider. And no matter if I make it a decimal fraction or a big whole number, anything, if I slap a negative in front of that a, it's going to take whatever shape, absolute value v I have, and it'll flip it downwards. Good question. All right. So here we're moving left and right. You need to have memorized it in that group with x. We're moving it left and right. It's the opposite direction of whatever sign. So here, since I had minus 2, it moved it over to the right 2. And if I throw a number in the back, let's say plus 3, it just moved it straight up. Okay, plus in the back is just up 3. If I made this minus 3, it's going to move it down here. All right, so that's what those 3 numbers are going to do. And all year long, when the same form comes up, the same thing happens. A always affects width and flip. The number in there with x moves it left and right. The number in there with for k moves it up and down. All right, so let's get back to our first example here. Example 1 asks me to graph this function. All right, so I've got 2, x plus 1 minus 3. Before I actually go back to Desmos and graph it, because you will be allowed to graph on Desmos, you'll have Desmos there with you during your test. I think it's super valuable to be able to look at this equation and see what it's going to look like visualize ahead of time what we're probably going to be looking at. When I see the plus 1 in there with x, that tells me I'm moving to the left, opposite of plus, 1 spot. Okay, so I know for sure my vertex to that point is going to go from the middle to the left 1 spot. And then because of this -3 back here, that's going to tell me I'm going to move down 3. So from the middle, I'm going to go left 1, down 3, and I'm claiming this is where my vertex point is going to be. All right, and then when I look at this 2 in the front, I know that's going to make it narrower than the parent function, so I'm going to have kind of a narrow v, and because it's positive, it's not going to be flipped. So I can kind of visualize. My point's going to be down here, and it's going to be a narrow v that comes up. What I don't want you to do is plot your vertex and then just draw 2 random lines that go up. I want you to find some points so you can show me exactly where it goes. All right, so I'm going to use Desmos for that. Coming back here to Desmos, I'm going to plug in y equals 2, absolute value of x plus 1, I think. X plus 1. And then in the back, I believe we had -3. Oops, where'd my other absolute value bar go? There we go. And now I need -3. Okay, so it looks like what I thought. My vertex is down here where I thought it would be -1, -3. So we're obviously going to plot that point. And then I got these other points here. This is going to cross my y-axis at 0, -1. It's going to cross the x-axis here at 0.5. And it's going to cross here at -2.5. So if I plotted these, it's going to really make my absolute value v look a lot more accurate than if you just drew 2 random lines. So let's go back and do that. All right, so I'm going to start with my vertex, left 1, down 3, which is right here. All right, I looked at it's going to cross the y-axis at -1. Over here, across the x-axis at 0.5, so I can put it right in the middle. And over here is at -2.5, so I can put it in the middle there. All right, so now I want to draw 2 nice straight lines so that this looks good. I'll just freehand it, but I'm pretty good at that. Okay, and there is my absolute value graph.
On the left side, what was the coordinates?
On the left side, on the x-axis, it was at -2.50. All right, let's talk about domain and range. Every time we talk about domain and range all year long, I'm going to ask you the same questions. I'm going to explain it the same way so that hopefully it sticks in your brain all year long and then you're good for pre-calc. Okay, first thing I ask with domain and range is how many points are on this absolute value graph? I've plotted 4, but there's actually more than just those 4, correct? There are infinity. Okay, so on this whole absolute value v, there are infinity points. One, you can tell because the arrows make it go up forever. Also, any line on a graph, there's infinity points because of all the decimals. So there are infinity points on this graph. So if I'm trying to write all of the x's for domain, I'm not going to write infinity numbers. Instead, I'm just going to write the smallest x, comma, the biggest x, which means every single number between here and here. All right, so that's going to look like this. My smallest x. When I'm trying to find my smallest x, I'm looking left and right. And specifically for the smallest x, I'm looking to the left because the smallest numbers are to the left, biggest numbers are to the right. I've got to go smallest to biggest, always. Okay, so I need to figure out how far to the left is this thing going to go. And it is going up, and you got to kind of ignore that. You want to just kind of visualize, is it going to keep getting wider and wider and wider? And the answer is yes. So it's going to keep going to the left forever, which we say is negative infinity. Okay, so my smallest x is negative infinity because it goes to the left forever. All right, then the same logic is obviously true for going to the right. This thing's going to get wider and wider going to the right as well. So this is going to go to the right forever. So I'm going to go comma positive infinity. My infinities always get parentheses and interval notation because you can't actually get to that infinity and touch infinity. It's not included because you can never actually get there. The other thing we could say for negative infinity to positive infinity, how else could we say that? All real numbers. Okay, so I would accept that as an answer too. Hey, Jordan, you got a question?
Oh, so like for domain, is it always going to be infinity?
For domain of, the question is it always going to be all real numbers? Domain of absolute value in my class will always be all real numbers because I will never give you sideways V's. You'll always get ones that open upwards or open downwards. So yes. However, I do not recommend you try to memorize, with lines it's always this, with absolute value it's always this, because by the end of the year we're going to graph so many different things and do domain and range of so many different things that you're going to get them mixed up. All right, let's do range. Range is a little bit more interesting. range, there's infinity points, so I just want to say from my smallest y